Welcome everyone. Thanks for joining our webinar today. My name is Duane Lewellen with Lewellen Associates LLC, and welcome to my beautiful office trailer on Whidbey Island, Washington. I work with Evergreen Technology Consulting, or ETC for short, to provide training and technical assistance for the commercial requirements of the Washington State Energy Code. And I will be your host for today's training. This webinar will be the fourth episode of our 7-part series about the 2018 Washington State Energy Code commercial provisions. We'll be focusing on key changes between the 2015 and 2018 Washington State Energy Code, and today's primary topic will be mechanical systems. Before we get started, let's cover a few housekeeping items. We have a lot of people joining this webinar today, so everyone's audio will be muted to avoid background interference. If you have questions, please feel free to post your questions in the Q&A during the presentation. At the end of the presentation, we'll walk through a few of your questions, and after the webinar, we'll put together a list of all the participant questions posted along with responses from our Energy Code Tech Support team. And then we'll send this out as a supporting resource to everyone who is registered. If you experience any technical difficulties, please communicate this via web chat as well. We'll do our best to resolve whatever issues you may be experiencing. This webinar is being recorded and will be posted on our new Washington State Energy Code website. Okay, let's go ahead and get started. Let me first introduce the team at Evergreen Technology Consulting, or ETC. My name is Duane Lewellen there on the left side of the page. I've been involved with Energy Code, Washington State Energy Code training and technical support since 1994. In recollection, this will be my 9th code cycle coming up here. So I've spent a lot of time around energy codes in Washington State. Chris Haas is our licensed electrical engineer, focusing in on our lighting and power systems. And of course, many of you know Lisa Rosno, who leads the Energy Code efforts for ETC there on the lower right-hand corner. Our team provides training and technical support for the commercial provisions of the WSEC. Our technical support comes in 3 waves. Basically, we have a telephone hotline at 360-539-5300. That you can reach us. We'll get back to you within 2 business days. You can contact us via email at com.techsupport@waenergycodes.com, or you can complete an online form on our website, which I'll be introducing to you here in just a few minutes, at www.waenergycodes.com. So we provide ongoing technical assistance, but also classroom and webinar training. As we start our 2020 series of training, gearing up for the 2018 code cycle, due to the COVID circumstances, we're starting off with a webinar series, which you are participating in today. Hopefully we'll be able to do in-person and classroom training if conditions warrant later in the year. We also administer technical support and compliance documentation through a new online compliance web tool. I'll be introducing the mechanical provisions of that to you today, but we're really excited on how this web tool will help you with compliance with the Washington State Energy Code. I do want to acknowledge the Northwest Energy Efficiency Alliance. It's through their generous support from their utility partners that we're able to provide technical services and training for the Washington State Energy Code to jurisdictions and the design and construction industry. I encourage you to visit NEA's website, Energy Code website. Not only do they help us providing training in the state of Washington, but they also support Energy Code efforts in Idaho, Montana, and Oregon. So if you're doing any work in those areas, please check out the NEA website and resource what they're doing in the code environment here in the Pacific Northwest. So let's talk a little bit about our education plan for this year. We've already completed episode 1 of our training series. That was on envelope systems, May 13th. Episode 2, mechanical systems part 1, was completed on May 20th. Both of those webinars are available for on-demand viewing through our website. The total system performance ratio is being supported by the University of Washington Integrated Design Lab and Pacific Northwest National Labs. They're going to be providing 3 training sessions on the application and use of TSPR and the TSPR tool. That first training was completed on June 3rd. 2 more trainings are scheduled for July 1st and August 5th. So if you were unable to attend that training on June 3rd, and are interested in learning more about the TSPR requirements in the code, please plan on attending the July 1st and August 5th webinars. Obviously today is episode 4, Mechanical Systems Part 2 today. And then in the future, coming up, we have Lighting and Electrical Systems webinar on July 15th, Additional Efficiency Credits webinar on July 29th, and Service Water and Refrigeration Systems webinar on August 12th. All of these webinar schedules are posted on our website at waenergycodes.com. This is also where you can register as we get closer to the dates. There will be a registration link, so check the website often to see if registration's open for the webinar that you're interested in attending. So a little update on the status of the 2018 Washington State Energy Code. The code was originally scheduled to go into effect July 1st, but that was postponed by the Governor of Washington until November 1st, 2020. You can download copies of the current edition of the 2018 Washington State Energy Code on the State Building Code Council website. It's worth noting that if you downloaded an earlier version of the code, there has been an update. There has been an update to the code titled Second Printing. So you want to make sure that you have the most recent edition of the code. Or if you've already downloaded that first edition, you can download the errata for the first printing, and so what those changes are, what specifically those updates are. And again, the code becomes effective November 1, 2020. So here's our disclaimer, ETC's disclaimer in terms of providing training and technical assistance for the Energy Code. We provide an unofficial interpretation of code intent. Our technical support team is not an affiliate, nor do we speak for the Washington State Building Code Council. Our technical support we provide is advisory only and non-binding. We have no authority. We are not a building official or an authority having jurisdiction. We just provide technical advice and training. The State Building Code Council does offer interpretations or answers that are made by the state to the State Building Code Council in response to official inquiries submitted by a jurisdiction. And so these official interpretations are published on the State Building Code Council website and are advisory in nature. I will note that there's already been about half a dozen answers provided for questions on the 2018 WSEC, so you can go ahead and check that out on the State Building Code Council website, so you have those as a resource guide. We also have a link to these interpretations on our website, so if there's something that specifically you think there's an interpretation on, you can check that out. These interpretations are not only on the Energy Code, but there's also interpretations on the International Building Code, Mechanical Code, and the other codes enforced in the state of Washington. So what's our agenda today? We're going to first talk about our compliance documentation web tool, a new requirement for data centers in the code, updates to the mechanical equipment efficiency tables, new ventilation requirements for Group R2 occupancies, Economizer exceptions, always a hot topic, miscellaneous controls updates, and new duct insulation tables. How exciting. It is our intent today not to cover every change and every provision in the code. We've selected these areas as some of the major updates or changes in the code to inform you as you prepare to comply with the 2018 provisions. So, the first thing I want to talk about is our new web-based compliance tool and website. This website at www.waenergycodes.com is meant to be a central clearinghouse or location for all things energy code for Washington State commercial requirements. You can become a member, log in, create an account, and become a member. It's free. There's a lot of useful information and resources. Until the 2018 code comes into effect, you can download the energy code forms, but also more importantly, this is going to be the location for our online compliance tool. I know many of you have already visited the site and have become members. If you're not familiar with the website, go ahead and enter it and make it a favorite so you can access it frequently as you work with energy code compliance. So a couple things that's available on our website. One is links to the actual code documentation itself. So we have links to the actual Washington Administrative Code, so the rulemaking portion of the code. We also have links to download the specific code, including the residential code and previous editions of the code if you need to do some research on a project that was constructed under previous code versions. We also have links to those question and answer series that I pointed out earlier. Also, if there's any changes made at the State Building Code Council, occasionally as we implement codes, an issue will come up, unintended consequences or a notice of something that wasn't intended in the code, and the State Building Code Council will issue what's called an emergency rule, which means that a code change will go into effect immediately. If there are any amendments or emergency rules with this code, we'll have a link to those on our website. We also have a very useful FAQ section of frequently asked questions. I think there's over 120 different issues that we've got answers to here. What you do is you select the topic. We've got a dozen or so topics that you select the topic, and then there's a list of questions and answers to those questions. Alternately, you can search those records for specific topics, say fan energy or fan power allowance, and see if there's any FAQ. We encourage users to search the FAQ out first if they have a question. A lot of questions are repetitive, and so for those issues that keep coming up, we've put together some FAQs. We've also got some fact sheets available on our website too for issues that are common in the energy code. So check out the FAQ first. If you don't find the answer to your question there, then you can contact us through one of those technical support channels that I talked about earlier. In terms of our technical support, our web tool, our web tool supports both new construction and mechanical alterations. So all projects mechanical, you'll be able to use our compliance tool to document compliance. It also includes a smart mechanical checklist. This replaces the checklist in the Excel forms. I'll demonstrate how that works here in a minute. But it's based on on your answers to question about the project scope and type of project it is. We will refine that checklist to only apply to, so that requirements that only apply to your projects are identified. We have our compliance documentation console, which I'll show you in a few minutes here, that it gives you the ability to document project information, run a compliance check for equipment efficiencies, including economizer exceptions, additional efficiency credit multipliers, and then finally a place to document pairing of heating and cooling system with associated DOAS system. What our tool does do is it defines or does a good job of verifying compliance with equipment efficiencies, additional efficiency options, economizer exceptions, and ventilation. It does not cover all of the control system requirements. That's through the SMART checklist. And then finally, the web tool generates an output summary report that you can use to submit to the jurisdiction to document compliance. So here's an example of our mechanical code requirements list. So based on the answers to the question that you input in the general mechanical information page, it will then identify which specific components and control requirements are required for your project. If it's a component that's not required, for example, in this case, anything that deals with Group R occupancy. If you don't have a Group R occupancy, then all those requirements specific to Group R are grayed out. They don't apply to your project, but they're not eliminated. They're still there, but they're just grayed so that you only have to deal with the components that are in bold text. And then the heart of our online compliance tool is the Mechanical Smart Console. This console is divided into 4 sections. The first section to be completed is the air system summary section. This is where you would input all of the specific air systems applicable to your project. You enter your DOAS systems first, because you're going to be able to link subsequent heating and cooling systems or pair them to the DOAS system. So this is where you would enter your DOAS systems, your single zone air handling systems, your multiple zone air handling systems. There is a project descriptor that separates single zone systems from multiple zone systems based on what you've entered in the general project information. So you enter all your air handling system information to include the area served, the type of airflow, the CFM, the ventilation air source, whether it's connected to DOAS or integrated ventilation. Once you've completed that, if there is a cooling section in your air handling system, you input the cooling source, whether that is air-cooled DX, water source heat pump, chilled water, and then that's where you would enter your cooling capacity and your required efficiencies. If there's a heating section, you would enter the heating system console. This is where you would enter any heating capacity, such as a gas furnace, hot water coil, electric resistance, heat pump, again with the capacity and the proposed efficiencies. And then finally, there is a radiant and convective section and passive section for systems that aren't associated with specific air systems, like radiant floors or electric baseboard heaters or chilled beams, and then that's where you would enter that information. If you get a nice green dot next to all your entries, that indicates compliance. If you've got a red dot, you're not in compliance, and it highlights the area that's not in compliance so that you can reselect and change that input, reselect your equipment, and make sure you're all in compliance. Also, this will also identify any adjustments for compliance based on Economizer exceptions for increased efficiency or the enhanced HVAC option. Once you've all completed that, then you can generate your output summary report. This has all the information required to verify compliance of your equipment with the provisions of the Energy Code. This is what would be submitted to the jurisdiction with your permit submittal. This can be either printed out and turned in at the time of permit, or it can be transmitted electronically. In addition to the console, we still provide technical assistance for the 2015 Washington State Energy Code. I'm sure those projects will be going on for a while. And in terms of compliance documentation, the Excel workbook forms are still acceptable for compliance with the 2015 Washington State Energy Code. You can download those forms on the website. Alternately, you can use the online compliance tool. Our tool is live for 2015 WSEC compliance. So if you want to get your feet wet and learn our compliance tool prior to the 2018 code going into the effect, that's great. That'll give you some experience on that. And then beginning in 2018, starting November 1st for permit submittals with the 2018 commercial code, the Excel forms will be retired. They will no longer be supported for the 2018 code, and the online compliance tool will be the only compliance tool pathway for documenting compliance with the Washington State Energy Code. So let's get into our mechanical portion here with data centers. So the Washington State Energy Code has adopted ASHRAE standard 90.4 for the HVAC system efficiency of system serving data centers. So the first thing we need to start with is what's a data center. So new definitions have been added to the code. So if you're trying to determine if your computer room or computer rooms are considered a data center or not, you need to refer to the definition. A data center is defined in the code as a room or series of rooms that share data center systems where they have a power density exceeding 20 watts per square foot of conditioned area and a total design ITE equipment load greater than 10 kW. So if that fits your specific room or series of rooms, it is defined as a data center and must comply, the HVAC must comply with ASHRAE 90.4. Now, if you have just a computer room, a single room, how to determine it's defined as a computer room, in which is its primary function is also to house equipment for processing and storage of electronic data. And it has an ITE equipment load less than or equal to 20 watts per square foot, or a design IT equipment load less than or equal to 10 kW. So smaller computer rooms that meet this definition do not need to meet the requirements of ASHRAE 90.4, but they still need to meet the requirements for HVAC system efficiency, economizer, envelope, and lighting requirements of the code. So let's talk about 90.4. So if you have a data center, per C403.1.3, the HVAC serving that data center shall comply with Section 6 and 8 of ASHRAE Standard 90.4. Now, Section 6 specifically is around the efficiency of the heating and cooling system, or essentially the cooling system serving that data center, and Section 8 deals with the power system, including UPSs serving the data center. Now, under Section 8, there's two options. You have to comply with either the maximum design component, or design MLC, or the maximum annualized mechanical load component factor, or the annual MLC, depending on climate zone. So, what are those factors? So, design MLC values is the ratio of the design HVAC load divided by the design ITE equipment load. So for example, the design HVAC load would include the cooling compressors, pumps, heat rejection equipment, and air handling fans at design conditions. So the total kW of that load divided by the total design IT load at 100% load. So in other words, when you have a design MLC value of 0.22 for zone 4C, that means that the HVAC load cannot exceed 22% of the design ITE load, or in climate zone 5B, 24%. An alternate path is to use a maximum annual mechanical load component. This annualized load component compares the efficiency or the load of the HVAC system at different load conditions divided by the IT load at different load conditions. And so this is an average HVAC load at 25%, 50%, 75%, and 100% load divided by the average IT load at 25%, 50%, 75%, and 100% load. So it's similar to that SEER rating, or seasonal energy efficiency ratio, on air conditioning units. So if you use the annualized mechanical load component, then in 4C you cannot exceed a ratio of 0.18, and in 5B you can't exceed a ratio of 0.17. It's worth noting you still need to comply with the envelope and lighting requirements of the Washington State Energy Code. This particular section only applies to the mechanical systems serving the data center. The climate zones, that earlier slide had climate zones, so it's worth taking a quick minute to remind everybody of the climate zones in Washington State. I know we have designers and permit applicants outside of the state of Washington. So Washington counties that are in climate zone 4C are counties in western Washington or west of the Cascades. Counties that are in climate zone 5B are in eastern Washington or east of the Cascades. If you're unsure what what county your project is located, what the zone is. You can check out table C301.1, and that will tell you which climate zone to use as you apply the energy code requirements. So let's get into some of the other changes in the mechanical provision of the energy code, and we're going to start off with some equipment efficiency table updates. We're not going to cover all of the updates, but some of the ones that are worth knowing about. First of all is single package vertical air conditioners and heat pumps. The efficiency values of that equipment has increased about 10%. So the minimum cooling efficiencies have increased to an EER of 11. It was previously 10.0, and the heating COP for heat pumps has increased to 3.3. It was previously 3.0. And this is worth noting because single package vertical air AC and heat pumps are commonly used on equipment buildings, portable buildings, small commercial buildings, temporary buildings, and because there are many energy codes across the United States, you can still purchase and buy equipment that has an EER rating of 10, so equipment that does not comply with the code. So just a heads up that if you're going to be specifying or working on projects that use single package vertical AC units or heat pumps, there are changes to the minimum efficiency requirements. Another change in the equipment tables is the addition of a table for air conditioners and condensing units serving computer rooms and data centers. This equipment is commonly referred to as CRAC units, computer room AC units, and they operate at different conditions than environmental cooling equipment. And so the efficiency of these systems are rated at different conditions. And so the code has adopted a table for minimum efficiencies based on AHRI standard 1360. You can see that the table is divided into equipment type. There's air-cooled, water-cooled, and glide-cooled equipment. You then have the cooling capacity of the system, the airflow configuration, and then you'll notice that there is a minimum sensible COP performance rating at 3 different entering air temperature conditions, or return air to the CRAC unit: 75 degrees, 85 degrees, and 95 degrees temperature. And this is to account for systems that are serving, for example, hot aisle, cold aisle situations, where we have increased or elevated return air temperatures entering the units. As you can see, when we do have elevated return air temperatures entering these units, the efficiency actually goes up. That's one of the advantages of separating the cold air supply and the hot air exhaust from these computer room racks. And so this accounts for that in the procedure. And so if you are specifying CRAC units, computer room AC units, become familiar with the new efficiency requirements and test procedure per AHRI 1360. Another table that's been added is for DOAS systems, DOAS air handling units, both packaged and split systems that also include a DX cooling or heat pump coil. Traditionally, DX heating and cooling equipment is not sized at 100% outside air condition. So when it's combined with a dedicated outside air systems, those rating conditions no longer apply. So the Washington State Energy Code has adopted AHRI standard 1920 to establish the minimum efficiency requirements for this type of equipment. There's a table for DX DOAS systems that do not include energy recovery, and then there's a second table for DX DOAS systems that do recover energy recovery. So depending on the layout of your system, one of these two tables will apply. Again, the table is organized by equipment type, by subcategory, and then the minimum efficiency requirements. Here's some new terminology for you to get used to. Often these DX DOAS systems are used when we have large amounts of outside air that we're bringing into our DOAS system. Especially now that DOAS has been expanded to Group A occupancies, banquet halls, conference auditoriums, gymnasiums. There may be on occasion where you have an event, you have high ventilation requirements, you're bringing in a lot of, it's a humid day outside, you're bringing in a lot of moist air and adding that load, increasing the humidity in the conditioned space and adding that latent load to your heating and cooling equipment. So an option is to go ahead and remove or dehumidify that moisture prior to delivering that air to the space. If the primary purpose of your DOAS system is for dehumidification, then you would use that ISMRE rating, which is integrated seasonal moisture removal efficiency. So the higher the rating, the more efficient it is at removing moisture. If you are using a heat pump coil operating in the heating mode, and so you're tempering air, outside air coming into the unit before being delivered to the space, then we use the integrated sensible coefficient of performance value. So those are the minimum efficiency values per AHRI 920 for that rated equipment. So let's talk ventilation, and specifically Group R2 buildings. So this is a significant change in the code for Group R2 buildings, which is multifamily buildings, and in the commercial code, that's multifamily buildings 4 stories or greater. So in the past, ventilation was handled through Chapter 4 of the IMC, and basically you were required to have either a whole house fan system with air inlets or a ducted distribution system through a central station air handler. That has significantly changed for the 2018 code cycle, and it's also changed in the provisions of the IMC, and so for the whole house ventilation. So that change is consistent with both the Chapter 4 of the Ventilation Code and Chapter 4 of the Washington State Energy Code. What the requirement is so Group R2 occupancies, which is dwelling and sleeping units, you are now required to provide a balanced ventilation system with heat recovery. That heat recovery shall have a 60% minimum sensible recovery effectiveness. The system shall be tested, balanced, commissioned in accordance with C408, which is the commissioning requirements. So you now are required to provide a energy recovery or heat recovery system in multifamily occupancies. This term balanced flow just means that the exhaust and ventilation airflows are within 10% of each other. We don't want to generate a large pressure differential between the conditioned space and the exterior environment, or within 5 CFM. So we have balanced, relatively neutral pressure relationships between the interior and exterior environment. Next, we're going to cover some new and changed economizer exceptions. So economizer exceptions are always an interesting topic in code compliance. Some exceptions have been deleted, some exceptions, new exceptions have been added, and some exceptions have been modified. So we'll go through some of the significant changes. First of all, exception 1 has been modified with systems with DOAS. So if DOAS has been installed in the past, prior to the 2018 code, you were exempt from economizer regardless of where the system was located or the type of system. That is no longer the case. Economizer is now required on all cooling systems installed outdoors or mechanical rooms adjacent to outdoors, whether or not DOAS is installed. So if you have an occupancy type that requires DOAS and you're using packaged rooftop units, economizer is required on those units. If you have a DOAS system and you're using package units installed at grade, economizer is required. If you've got DOAS and you're using single package vertical AC heat pump units, as we talked about earlier on portable classrooms, economizer is required. And if you're installing split system DX cooling, water source heat pumps, chilled water fan coils located in equipment rooms adjacent to outdoors, an economizer is required. So this significantly expands the economizer requirements even when you're using DOAS. The exception for heat recovery VRF systems has been eliminated. That doesn't mean that you have to now provide economizers for VRF systems. We just went through that. So if your VRF, variable refrigerant flow heat pump system, does not include equipment located outdoors or in an equipment room next to outdoors, it does not have to have economizer. So if it's fan coil units above the ceiling, wall mount units, console units, then economizer is not required. You'll qualify for exception 1 with DOAS. New exception 7 for spaces with year-round cooling loads served by chilled water systems and heat recovery chiller. This is applicable to spaces with high internal heat gains like labs, research facilities, clean rooms, biotech, where they have year-round cooling loads and they can actually recover that heat energy through the chilled water system and transfer that to a hot water loop for heating. There is a new economizer exception number 10 for systems exempt from heat recovery. This would include systems serving makeup air for kitchen process exhaust, laboratory fume systems, systems with cooling energy, and systems with dehumidification and energy recovery. Control updates. Now, we're not going to cover all of the control requirements of the Washington State Energy Code, but I've picked out a few updates that I think you may be interested in. The first one is vestibules. Vestibules are now required in the code for certain building types over certain floor areas, for main entrances in buildings over a certain size, and so we're seeing more vestibules installed in buildings. It is common to provide some kind of space conditioning in the vestibule to temper that vestibule on cold days as a transition space between outside and inside. And so there's been a change in the code now that requires control of those tempering systems. So if you install a heating system in the vestibule, let's say that you've got an electric wall heater in there or an overhead radiant heater in the vestibule, then you shall have a control on that that locks out that piece of equipment if it's above 45 degrees outdoor temperature, or is controlled by an interior temperature control set to 45 degrees. So you need to have a thermostat either can set no higher than 45, or you can control that through an outdoor air lockout, perhaps through a DDC, building automation system. If you have both heating and cooling systems supplying that energy to the vestibule, then you shall have an independent control located in the vestibule that limits the heating to no higher than 60 degrees and the cooling no lower than 85. And then finally, if you have no heating or cooling in the vestibule, it's not conditioned at all, that's fine. There's no change, nothing impact you in the code. And then if you use just transfer air, so if you transfer air through the conditioned space into the vestibule, air that would normally be exhausted or exfiltrated through the building, that's fine. You can still continue to do that, and there's no specific code requirement. Exhaust systems. Exhaust systems have been left out of the control requirements, interestingly enough. When you look at automated controls, it focuses on heating and cooling systems, but failed to represent exhaust systems. And so we have a specific now independent control environment for exhaust systems. So in other than group R occupancies, exhaust systems that serve conditioned spaces shall have an automatic time clock control, a thermostat or programmable control to operate on the same schedule as the HVAC system. It makes no sense to operate the exhaust systems when the spaces are unoccupied. And so that can be done with an independent time clock. It could be a programmable controller. It can be connected to a thermostat, or through some sort of centralized building management system. Some exceptions to that are systems requiring continuous operation. Obviously, you wouldn't want to shut off the exhaust fan in that. And then also systems controlled by occupancy sensors. So the individual exhaust fan in the restroom, if it's shut off automatically, it doesn't need to have a time clock control. And so as long as you've got that occupancy sensor control, you're fine. This will be an interesting provision of the code as we move through into the 2018 code compliance and enforcement for door switches for HVAC controls. I know we've all in our lifetime walked down a retail street on a hot summer day and the retailers have the doors open, inviting you to come into their cool air-conditioned space and spend money. That's great for the retailer, except it wastes energy and increases their energy bills. And so there is a new control provision for doors that open directly from a conditioned space to the outdoors. So that if you have those instances, then and if the doors are open for more than 5 minutes, there shall be a control that will disable the heating or the thermostat to 55 degrees or lock it out. So no heating or reduce the set point. And the same thing on the heating side, either disable the cooling or increase the set point to 85 degrees Fahrenheit. Hopefully this will reduce the energy loss going out through the door. And then if the occupants begin to get uncomfortable, they can close the door and reset the temperature set points and the lockouts. Now, obviously, there's got to be some exceptions to this. Entry doors with vestibules are exempt from this requirement. Alterations to existing buildings, and obviously loading dock doors that would need to be open for the transfer of material. Another control upgrade or addition is the control of decorative combustion air appliances. I'm sure we've all stayed at a hotel or motel and there's been the fireplace in the lobby that's operating regardless if anybody is enjoying it or in the lobby. And so the code for these type of appliances now requires that there be some kind of local on-off control. I make the analogy with the hot tub in the hotel. You know, if you want the bubbles on, you hit the timer and you get 15 minutes of bubbles. And if you want more bubbles, you hit the timer again. And you can enjoy those bubbles, and then the energy waste doesn't occur during the entire time that the hot tub is open for occupancy. This is true for that. If people want to, in this example, sit down at the table and want to have the fire going, they can flip a switch and get an hour of operation, and then it'll go off automatically. If they're there for more than an hour, they can hit the switch again. Or you could use an occupancy sensor to automatically control whether or not the decorative appliance is operating if somebody's in the room. Couple few more control things worth. If you're involved with permitting designing of hotels and motels greater than 50 guest rooms, this will be an impact. So Group R buildings greater than 50 guest rooms, we've had a requirement in the code for these larger Group R1 buildings to have some sort of automatic control of the heating and cooling in the guest room. When the guests leave, it shall be automatically controlled either through key card or aux sensor. That control now has expanded to the exhaust system that serves that guest room. So in addition to reducing the heating and cooling, you shall now provide controls to automatically turn off the ventilation and exhaust fans within 30 minutes of the occupants leaving the room. It makes no sense to reduce the heating and cooling, but allow the exhaust fan to continue to waste fan energy and conditioned air when nobody's in the room. Now, if you've got an independent exhaust fan serving that room and you have that controlled by an occupancy sensor, that's great. You comply with the requirement. If you've got a central exhaust system, you're going to have to provide some isolation devices to each guest room that are capable of automatically shutting off the supply of outdoor air and exhaust air from the guest room when it is unoccupied. And then some control shut-off dampers for building isolation. New automatic or motorized dampers have been a control requirement in the code, and that's been problematic, especially on small systems. And so there's been some revisions to this requirement where gravity dampers, non-motorized dampers, are acceptable for outside air intakes or exhaust capacities that do not exceed 4 CFM regardless of occupancy. This was previously limited to Group R occupancy only, but that Group R restriction has been removed. So now you can apply gravity dampers to small air systems, including DOAS systems or ERVs or HRVs. And then also you can use gravity systems for system serving areas which require continuous operation for 24/7 schedules. So some new things there that'll give some relief on having to provide motorized dampers on small air systems. And then the last control item we're going to touch on here is fan controls. In the previous code, in the 2015 Washington State Energy Code, multi-speed or variable speed fan controls were required on DX cooling systems greater than 5 tons. That scope has been reduced to 3.5 tons and above. So 3.5 tons above, DX cooling, package or split, now requires multi-speed or variable speed fan controls. And then also on chilled water systems, the fan motor size limit has been reduced from 5 horsepower to 1/4 horsepower for chilled water. So variable speed or multi-speed fan controls are required. And then finally, if you've got a unit with Economizer, Economizer is required to have a minimum of 2 speeds of fan control during Economizer operation. So the last section we're going to cover here are some updates to the duct insulation requirements. So I'm really glad that these tables were added to the code and that the previous outdoor air ductwork requirements were amended because they were in a narrative format and was hard to figure out. So we've got several new tables to clarify the requirements for ductwork insulation. If it's ductwork that's serving outside air to a DOAS system, an ERV, or an air handling system, we now have specific insulation requirements depending on where the ductwork is located and whether it's upstream or downstream from an isolation device, based on the airflow, based on the climate zone, and then a defined minimum insulation value. So, for example, if you've got outside air ductwork that's serving an air handler, the minimum outside air is greater than 2,800 CFM, and it's located in climate zone 4C, it's required to be insulated to R16. So hopefully this will clarify the insulation requirements for outdoor air ductwork connected to air handling systems, including DOAS systems. We also have a new table for ductwork supply, return, exhaust, and relief air ductwork, and it's a similar format. Based on the service of the duct system, the duct location, and the climate zone, you can easily then identify the minimum insulation value required for that. Again, it depends on where the ductwork is located, whether it's outside the building, it's in an unconditioned space, it's part of the building envelope, or it's within the building envelope. But as long as you can identify that and the climate zone, you can determine the minimum insulation values. And then finally, since we're using a lot more DOAS and ERV systems in our building, the table is expanded to include return or exhaust air. Again, if you've got return or exhaust air systems that are within the conditioned space, connected to an ERV, depending on the climate zone, the table defines a minimum insulation value for that ductwork. So it's time to wrap it up for today. I want to remind everybody that the Q&A session is going to happen after. We'll go live and do the Q&A session. So yeah, if you have any questions, now is the time to add those to the Q&A. I do also want to remind everybody of our schedule for our future schedule for our online training sessions. As I mentioned earlier, episodes 1 and 2 have already occurred, and you can view those streaming webinars through our website. The introduction TSPR is being provided by the University of Washington Integrated Design Lab and the Pacific Northwest National Labs. The first session was held on June 3rd. 2 more sessions are scheduled for July 1st and August 5th. Obviously, you're participating in the Mechanical Systems Part 2 session today. Episode 5, Lighting and Electrical Systems, is scheduled for July 15th. Episode 6, Additional Efficiency Credits, on July 29th. And Service Water Heating and Refrigeration Systems on August 12th. I encourage you to become a member of our website and check often. This schedule is posted on, this training schedule is posted on our website, and as we get closer to these dates, we will also provide a registration link. And again, take advantage of our online and technical support services. You can reach us through our technical support website at waenergycodes.com. You can send us an email. You can contact us via phone. You can complete a form and address your question. And also take advantage of the valuable resources and the compliance tools that are available to you on the website. So thanks for joining our webinar today. I really enjoyed, and we're going to be now transitioning to the live portion of the webinar and addressing the Q&A. Thanks again.